This movie will provide an overview of the Enroute AutoToolpath process. Enroute AutoToolpath is a process that allows you to take files from a parametric design software such as KCDW, Cabinet Solutions, RouterCAD, 2020, or even using AutoCAD to create your own layered DXF output. Bringing these DXF files into Enroute's AutoToolpath interface, which has already been set up with the corresponding toolpaths. So basically you're going to import this, select your ATP configuration file with all this information, and then hit the button and you'll create the output. The last step in the process here is just to go and run the jobs. So this is a pretty seamless interface between the cabinet program and outputting to the machine. Let's give you a brief overview how this works. First, I'll click my Auto Toolpath interface button, or I can go to the File menu and get there. I already have this set up, but the design application should match the program you're using. Here we'll clear this out of here and show you the next step here, which would be to load a TXT file that is either an XML file or a comma separated value file that will give you some specific parameters about each of the parts and indicate what their length, width, and thickness are, the material type, and so on. So I import this cut list file. Then I load my saved AutoToolpath configuration file. I'll output some parts using a specific file name and an output path, which is right now going to my AutoToolpath folder. Let's actually change that to our current install AutoToolpath folder. And if we're going to create output files here, we would have this checked, and that would be part of our ATP. And we'll hit Process KCDW. So this is going to take each of these parts, toolpath it based upon the layer name, nest everything together that belongs in the same kind of material, and then create the output files. Here I have two output files that were created, 3/4 millimeter CNC and AutoToolpath test _ millimeter. So we have a sheet of 3/4 millimeter that's required and a sheet of 1/4 inch millimeter. When we hit OK, we already have these files ready to cut, and we would not have to really do anything further here. But if we want to, we can come in here and make some changes and then re-output the file. Another thing we can do here is take a look at the actual part. Now I have a layer printout that was for a different sheet here, but this is an example of the type of printout. It would include a layout of the nested sheet, and it would have the name of the parts and their location on the sheet listed in a list down at the bottom. And we do it in this format because if you have a long Y and a short X, then the names tend to print across each other. So this allows us to just use a numbering system to determine where all the parts are. So using this as a guide, you can then cut each of these sheets out. And if we do a little bigger job here, we'll take another look at this. And here we'll clear out this job and select a new job. That's actually the same job. Come here and choose the example CNC list. This one has a few more parts to it. The other job just had about 7 or 8 parts, and this has 51 parts. You can see we have a bunch of layer names, and when you're doing this auto toolpathing, each part you create is in an individual DXF file. Each geometry within the part is in a different layer name. So what Enroute does is reads the layer names, applies a pre-existing save strategy to each layer name, and it allows you to have a second strategy for small parts as defined by a tolerance. So anything under a specific tolerance is considered big, anything below it's considered small. All right, we have an ability to make your cut depth read off of the files, off of the geometries, and this is the use depth option. And by using depth, we're having the parametric program place the contour in a specific z depth, and we're using that to determine the depth of the cut. We also have toolpath, nest together, and output selected here, and we'll explain all those in a different movie. The next tab you have to have set up is ordering and nesting. Of course, we always want to do our cutouts last and drills first. So we have the ability to set a priority here where strategy is the most important concern, and we're going to output in this drills, then island fills, and offsets. And you can achieve a similar result by setting your tool order in a specific manner, and then choosing tool as the highest priority. So this little area will determine the output order. Now we have some nesting parameters. We've nested things with a pretty close gap to fit as much as possible on the sheet. If you wanted to have more space around the edge or between the parts, you can control that here. And the orientation of the parts, we're orienting it to the middle left. Down here we have our default plate size that is just used for which plate shows up and en route after the job is processed. The final thing here would be to make sure that we have our, if we want to create output files, that we'll have that selected. To create a printout of the parts to show where the parts are on each sheet, we would click on this part. And if there's label output, we can do that as well. We can also process as a single part for point-to-point type operations where you want to cut out each piece separately and then maybe do some types of alternate programming on it. So you can process everything as a single part, which is mostly something done on point-to-point machines. All right, and then finally the name of the part and where you want to output it to. Let's just put test 2 here. All right, and now we'll process these jobs, which is the one that's a little bit bigger job here. So once again, the program here is reading each of these 60 or so DXF files, reading each of the layer names of the parts, and assigning the appropriate strategy. Some of them get cutouts, some get island fills for internal cutting. And then once this process is done, each part will be nested together as a single piece with all the other parts. And we're looking to put things that belong on the same material together. So the material type becomes important here. En route at the end of this process will let you know how many sheets you need of each material. And we take into account this thickness when creating output files. So for instance, if you're surfacing at the bottom of the plate or surfacing at the top of the plate, these values, your end up cut thickness will be correct. And in the case of the bottom of the plate, this specific material thickness is used when determining how much above 0 the part needs to go. So it's an important variable when surfacing on bottom of plate. So once we're done here, we'll have the output files, the layer printouts, and an en route file that will allow us to go in there and make changes if needed after this process has been done. All right, so here we get a list of all the output files that were created. Oh, I forgot to make that change as to where it's going permanent, so it's in a little different directory. And if I hit the OK button here, that'll bring us into the en route file where if we needed to make a little change, we could do that. All right, now if we come up here to the area where we can see all the layers, we can count these layers and know how much we're going to need of each material. So here we need 7 sheets of 1/2-inch plywood. We're going to need 4 sheets of 1/4-inch plywood. And if we scroll down here to the bottom, we need 2 sheets of 3/4 melamine. We can also scroll through this list here and see what each of these pieces looks like. And there's our first sheet of 3/4 or 1/4-inch ply. And then here's the 2 sheets of 3/4 melamine. So these files are output and ready to cut, and you have a layer output that shows where all the parts are, and you can have labeling if you've purchased that option. Well, this has been an overview of the En-route Auto Toolpath functions, and we'll do a little bit more specific information about each of the steps in this process in a separate movie.